Chemistry video 2.1. Here we're looking at the metric units and prefixes. This is one of the topics of the year where I feel like students feel like they have a pretty good grasp on it, but in reality there's a lot of misconceptions or a lot of silly mistakes. So let's try to correct those while we're going through this video and in practice in class. Main ideas are to define what the SI base units are for time, length, mass, and temperature, and also to be able to convert between the units of the metric system, like prefixes like centimeters to meters or kilometers to centimeters. Just a reminder, put away all your distractions, maximize this video screen if you can, pause, rewind frequently while going through this practice, and write some questions in the margins if you have any. Here we go. So, section 2.1. Why do scientists use a common system of measurement? Okay, all scientists use the metric system. Why do they do that? Well, they do it because it's easier to share and verify each other's data. In the English system, we like to use our pounds and we like to use our Fahrenheit and stuff. Well, most of the world likes to use kilograms and they like to use Celsius. And it's hard to verify each other's work if we're doing something different. So the scientific community has established that they're going to use the metric system as their standard of measurements. And also why? Because the metric system is based on a power of 10. It makes it a lot easier to count things as well. The name of the system that we use is called the SI system, or the Système International des Unités. That's my French there. Okay. It's an international community that got together to determine the standard units. And they have established that the standard unit for time in science will be the second. It doesn't mean that you can't record things in minutes or hours and stuff like that, but the second is the base unit that we most often use. Length is going to be in meters. Woo. Length is in meters. Mass, how much matter there is going to be in grams. You can also put on there or the kilogram. Kilogram is also very common. And temperature. Temperature will be given in Kelvin or Celsius. Kind of depends on what you're doing, and we'll visit those later this year. All of these are part of the metric system except for Kelvin. Alright, the purpose of using prefixes now. Well, prefixes are better to use to describe the range of possible measurements. Okay, so for example, you don't want to say how far it takes to get from Fargo to Minneapolis if you're going to say how many centimeters it is. It's going to be a lot of centimeters, so we end up using the miles in the English system, or the kilometer would be better. So here we go. So what would be the better use for the following? Why don't you pause and see if you can answer those first, and then unpause when you're done. Okay, so the length of your finger, probably best to measure that in centimeters, because the centimeter is about the length of your pinky, and that's a good length there. The distance between Fargo and Minneapolis, we just told you that would be the kilometer. It's a long distance, so a large unit. The width of your pencil lead is given in millimeters, and you can actually see on the side of your pencils with the mechanical pencils, it's usually like 0.5 or 0.77 millimeters. And your height is most oftentimes given in meters in the metric system. So prefixes better describe the range of possible measurements, so your numbers are nice. And when we talk about nice numbers, we mean like 1.7 versus 1,700 millimeters. My height is approximately 1.7 meters. So just better numbers come when you use the prefix system appropriately. So the metric prefix system, you probably remember learning about everything like this. So once upon a time you learned that kangaroos hopping down, drinking chocolate milk. Drinking chocolate milk. And the base unit is right between those two D's there. Kangaroos hopping down, base units, drinking chocolate milk. Those are your prefixes to help you kind of remember how to move the decimal point. And I like that. And down here we have a thing called micro. It's like a U, but it's kind of a funny tail in the front there. So it's called the Greek letter mu. And that's a symbol for micro, like micrometers or micrograms. Okay, so you probably learned how to convert in the prefix system doing something kind of like this. And I like this. However, sometimes you guys forget how many times to jump. Like, this is actually 3 steps down below here. So I kind of a new way for you guys to learn the metric system and prefixes and how to do that. So why don't you give my way a try and see how it works for you. So to get started, let's fill in our table here. So your prefix, the first one's going to be giga, and that's the big G, and it could be a little g sometimes, but big G. And that's going to represent 10 to the 9th, which really means billion. Next we have the prefix mega, capital M, which means a million, or in scientific notation, it'd be 10 to the 6th power. Then we have kilo, symbol is K, which means 1,000 base units, and that's 10 to the 3rd for a factor. So remember, this means that 10 to the 6th means a million, 10 to the 9th means a billion. Notice how it jumps by 3's. Okay. Now in your sheet, I'm kind of missing a couple that would fit into here. So the ones I'm missing are H would be hecto, and that'd be H, and that represents 10 to the 2nd power, which means 100. And then we would have deca, which is either DC or DK. I like DK better. And that's just 10 to the 1st power, which means 10. And then we have right here, this is the base. The base fits in right here. And base means 1 of something, which is like 10 to the 0 power. Then we go down to deci, which is little d, and that represents 10 to the negative 1. And 10 to the negative 1 basically means 1 over 10 to the 1st power. That means 1/10. Then we have centi, which is little c, and that's 100th. So 10 to the negative 2nd, which is again like 10 over 10 to the squared. So it'd be 1/100th. Then we have milli, little m, which is 10 to the negative 3. Then we have micro, which is, again, it's a Greek letter mu. It's like a U with a tail in the front, 10 to the negative 6. Then we have nano, which is n, and then that's 10 to the negative 9th. And I like that one, nano, 10 to the negative 9th. A lot of n alliteration there. And then we end it with pico, p, and it's 10 to the negative 12th. All right. So this is our prefix table. And really what I want you to notice here is you guys, once upon a time, remember these guys fit into here, you guys like to bounce your things up and down by steps. And it goes like 0, -1, 2, 3, nice steps there. But when you go to do a jump from here to here, or you jump from here to here, or here to here, those jumps actually go by 3. So on the stair step model, that'd be actually like jumping from here, and then 1, 2, 3 steps. So whenever they vary by a factor here, and it's these little numbers in the upper right corner here, when they vary by more than 1, that's how many steps you have to do there. Okay? So let's kind of practice and show you what I mean. So, lots to get rid of here. There we go. Okay. So, a little practice here, the stair step method. The first thing I want you to do in your space on number 5 here is I want you to draw some stair steps that go down and to the right. And say that. Down and to the right. And then retrace it. Down and to the right. One more time. And now you're going to go backwards and you're going to say up and to the left. So, this little stair step like this helps you remember something. When we move down this table, when you move down the stairs, look which way we're moving. We're moving to the right, which is the way you move your decimal point. And when you move up this prefix table, when you move up the stairs, you're moving to the left. So one more time. When we move down, we move to the right, this direction. And when you move up, you move to the left. So let me show you how to practice with letter A here. So letter A here, we have 1,200 meters, and we're going to convert to kilometers. A meter is a base unit. Now don't confuse this with milli right here. If we truly had millimeters, it would be 2 m's. So if you ever have just one letter here, that's a base unit. If you had m in front of something, then it would be milli. So we have just meter, which is a base unit, and base units are right here. And this represents 10 to the 0 power. And now we're going to convert to kilometer. And kilometers, you can see right here, is 10 to the 3rd power. 10 to the 3rd. So, are we moving up or down? Well, we start with our base unit. We start here, and we're going to end at kilometer, which is right here. So we're going up. Now, what's the difference between these two numbers, 0 and 3? That would be 3 spaces. So we're going to move 3 places. We are moving up the stairs. So we're going to move up, and when we move up, we are moving to the left. So we're going to move 3 to the left. So if you have 1,200, there is no decimal point right now, so where's it technically at? It's at the end. It's technically right there. Okay, it's right there. Then we're moving 3 to the left, so 1, 2, 3. So now we end up with 1.2 kilometers. And that's how it's done. So, got a few more practice ones for you to do here. I'd like you to maybe try B, if you think you can do it now, or watch me do it. But letters C and D, I would like you to do those ones completely on your own, and then unpause to see the answers when you're done. Okay, on 5b, we are at meter, which we just saw on the previous page is 10 to the 0, because that's a base unit. It's all by itself, it's a base. And we're going to go to centi, and centi is right here, and that's 10 to the negative 2. So 10 to the negative 2 is what centi stands for. And we are going to be going down the stair step. If we go back a page again, base unit is right here, meter, and we're going down. And when you go down the stairs, you're moving to the right. So we're going to move to the right, and the difference between 0 and negative 2, the amount of space between those two would be 2 steps. So we're going to move 2 to the right, so 0.025 becomes 2 to the right, fits in right there, becomes 2.5 centimeters. Good. Okay, remember, C and D, you're doing your own, and then you're going to check your answers when you're done. So, assuming you've paused by now, here's how we do it. So we start off with the prefixes. We have micro and milli. Micro, previous page, micro is 10 to the negative 6, and milli is 10 to the negative third. So we have 10 to the negative 6, and 10 to the negative third. And we start at micro, so we're starting right here, and we're going up to milli, so we're going up. And when you go up, you move to the left. So moving to the left. And the difference between negative 6 and negative 3, the space between them would be 3 steps between them. So we are going, gotta go back one more time. Oops. Micro to milli. So we're going up and to the left. We're going to move it to the left 3 places. So if you have 46,500, the decimal point is technically right here at the end. Now we're move it 3 to the left. 1, 2, 3. So you end up with 46.5 milligrams. That's equivalent to 46,500 micrograms. Okay. Okay, next one. So first thing is to find out what kilo and nano stand for. Kilo, right here, represents 10 to the third. Nano represents 10 to the negative 9. Okay, so we have 10 to the third and 10 to the negative 9. So first of all, the space between those two would be actually 12. And the way to think about that is like a number line. So here's 0, and we go negative 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Negative 9. And here we have positive 3, and that'd be up here. 1, 2, 3. And the space between them is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. The space between negative 9 and 3 is 12. So we're going to move this 12 places, and we're going from kilo to nano. Kilo is way up here, so we're starting up here, and we're going to go down to nano, which is this way. We're going down. And when you go down the stairs, you are moving to the right. So we'll be moving our decimal place 12 to the right. So here we go. And notice I also have them kind of grouped by 3s, so it's 3, 6, 9, 12, right there. So 550 nanometers is your final answer there. Okay, so hopefully this is making sense. Come ready to practice in class a little bit, and if you have questions, make sure you speak up. Great job.